Hi, I'm Matt Campbell, Professor of Mechanical Engineering at Oregon State University. I'm here to talk about my point of view on the future of engineering design research. This is for the NSF workshop in November 2015. I've organized my thoughts with a sort of push-pull kind of analogy to market pull and technology push. So let's start by looking at the pull. I believe that design must keep pace with manufacturing. And with the 3D printers today, we can generate a variety of complexity of shapes. We can even create shapes with multiple materials, yet our computational drafting tools do not handle those well. So we need methods to design single parts better. We can automate methods that, for example, design a shape given the constraints of a particular manufacturing process, or vice versa. If we have the shape, design the manufacturing processes or plan the manufacturing of that part. We should be able to pull that off. Second, design needs to keep pace with technology. I'll look at an analogy to electronic design automation. Moore's law is typically used to show how the complexity has grown in that field. And if you look about where we are in electromechanical systems, we're at about a 1980s level, and that's where these electronic design automation tools really took off. No more are we designing things on paper like this picture from Bell Labs in the 1980s. So in order to do that, we need to design multiple parts better. How can the computer help us handle thousands of parts and the issues between them? We need to figure out ways to mediate and solve trade-offs between parts, and we ought to be able to automate common tasks like the design of a gear train. There should be techniques available that solve those menial tasks that we are doing over and over again. So what's the push? What's the synergistic technologies to help us? And so I'm going to pitch this old idea of artificial intelligence in design. No longer are we in AI winter. We have a lot of great buzzwords these days that talk about how amazing AI is. We really need to leverage that in design. Let me give you some examples. Based on my previous slide, we could do some interactive shape design where AI fills in the gaps to make optimal shapes. We already do this with some topology optimization, but I mean beyond minimizing distortion energy, like minimizing cost or minimizing towards some dynamic response. We also should be able to do these assembly-wide improvements, AI to handle issues between custom parts and making sure that they meet with OEM parts on a large scale. And here's where we could take advantage of big data and deep learning. Another idea for deep learning is the idea that we could anonymously collect data and develop virtual experts to provide insight to, say, for example, the reliability or sustainability of a particular candidate assembly that we're looking at. So I'd like to see us work more towards a combination of previous design theory research with artificial intelligence. I think we could do a lot in that area. Thank you for listening.